Yep.
Okay, so the next job to do is to replace the resistors and, as it turns out, one capacitor on the valve tester. So we'll get and sort that out, before which I'll just show you I've laid out all the replacement new resistors and capacitors on the graphics so that I can easily know which new replacement item goes where. So that's quite a handy thing. And now we'll get the old burnt out resistor off first. I'm using a adjustable temperature soldering iron, which is a very good tool. So you can alter either your temperature on whatever type of job you're doing. There. Right, just trim the ends of the connectors to size. And then that should be fine, yep. And just tack them on there. There we go, that's the one. There we go, that's done. Now we just have to do that for the other half a dozen or so, and we're good to go. Okay, so let's get the other one, the next one done, which is this capacitor, not capacitor, resistor here. This one looks like it's been heated up quite a bit, melted a bit at one end, so that's definitely a bad one. Right, so we replace that with a new 10K resistor. The tags are a good length on that, so we don't need to cut it. One thing I like to do is make sure the resistors are lined up in the same orientation, so the silver band on this one is in this direction, so I'll do the same on this one, so it'll be the silver band in that direction. Some people think it might make no difference, but I think it's, if you replace it in exactly the same way that it's put in, then can't go wrong. And then you can bend that down there. Yep. And solder that end in. Fine, so what I'll do now is carry on doing all these and then show you the finished result. Okay, so now I'm putting the capacitor on after finishing the resistors, which are all finished now, put in place. But what I need to do before I put the new capacitor on is find the polarity of it. So, using an oscilloscope, we connect it up like that, get the oscilloscope as good as we can onto the adjustments, and then when you put your hand over the capacitor like that, the oscilloscope shows a wave pattern that increases or decreases as you put your hand on the capacitor. Now that's the wave pattern with the wiring connected this way. So now what we'll do is change the wiring over, turn it around like so. And now do the same test where we put our hand onto the capacitor and it doesn't show hardly any variation, or anyway. So we know now that is the correct configuration for the capacitor. So I'll take a marker. Some capacitors are marked, some aren't. This one wasn't marked, so we put a ring around this end to show us which end is which on that one. And now we have to do the same to the old capacitor, just to double check to make sure that the polarity, if you call it that, is in the correct order. Right, so we put that there. Do the same test with our hand. Deflects quite a bit. And then turn around on the wires. And that deflects a huge bit. The deflection on that. So the correct wiring is this, with the black on this end, which coincides with the fact that this particular one was marked with a ring on this end, so that was marked correctly. So we just try it again, and that's the lower of the deflections, so we're okay on that. That's fine. So now we know that the old capacitor was facing in this direction and the new capacitor will be facing in the same direction as so. And now, as you can see, the capacitor has been fitted. Because it was quite a bit larger than the original and would have fouled the bottom of the case, I've put some extension wires on it and zip tied it down below and then wired it into the circuit board. So hopefully now all we have to do is connect it up and test it to see if it works. Fingers crossed.